Hello everyone. In our previous lecture, we had started a chapter of acid and bases and we had completed the acidic part. In this chapter, we are going to discuss about the basic and we are going to discuss about the salt part. Okay, so let's start. Remember, in our previous lecture, we had a discussion that bases are the substance which gives OH minus ions in aqueous solutions, right? And we had discussed the three theories like Arrhenius theories, like Bronsted and Lowry theory, and then Lewis theory. Okay, like Arrhenius said, they are the substance which form H2 minus ions in aqueous solutions. Bronsted and Lowry said they accept protons. Lewis said they donate electron. Remember? And then we had discussed that they taste bitter. They taste bitter. Also, we had a discussion over some different indicators which we used for the bases, okay, and for the acid identification. And we also said, like, to check the intensity of a substance to be acidic and bases, we use a scale known as pH scale, in which neutral value is 7. So if anything is below 7, it will be acidic. If anything is above 7, it will be basic. Okay, so we had discussed these things, right? So today we are going to discuss about, in this lecture, some other basis phenomena. Okay, so let's start. First thing is that bases also having some uses, and we use some common bases in our daily life. Like, first is a milk of magnesia. Milk of magnesia basically used whenever you're having some acidity problem. Okay, whenever the HCl which is found in your stomach releases in high quantity, then you have to neutralize it by using milk of magnesia. Okay, thereafter we using toothpaste which is also basic, then the soap we use is also basic. The detergent we use is also basic, and you can say the slaked lime which we use is also basic. Got it? And one important thing, remember, your milk which is having nearly 6.5 pH is acidic. The common milk which we use in household is acidic because it's having nearly 6.5 value. Got it? Whereas the human blood is having value of 7.4 pH. So you can say it is slightly basic. Got it? So remember these things. Okay. So now we are going to discuss about the reactions of base with several things. Like in the previous, we had discussed about the reaction of acidic. Now we are going to discuss about the reaction of basic. So our first will be reaction with metal. Okay, so whenever base reacts with metal, it gives salts and hydrogen. So you can say the same thing will be happen like the thing was happening with the acid. For example, if this is zinc and this is base, you can say any base which we have taken up, like aluminium plus sodium hydroxide. Then it will give sodium aluminate plus hydrogen. In this scenario, you can say aluminium is a metal, sodium hydroxide is a base, sodium aluminate is a salt, and hydrogen is a gas. And the same procedure will be followed like it was followed in the metallic part. Got it? Now, the other reaction is reaction with the second case is reaction with non-metal oxides. Then it will give salts and water. And how can I say that? Because remember one thing, here I want to share one thing with you is that metal oxide, non-metal oxide, they having certain things like metal oxide is basic, non-metal oxide is acidic. Okay, so whenever base reacts with acid and whenever acid reacts with base, they always give neutralization reaction. Okay, so always remember this thing. Got it? Whenever acid react with base or whenever base react with acid, there will be only one situation which we call neutralized situation. Okay, so whenever the base reacts with non-metal oxide which is acidic in nature, it gets neutralized, and in every neutralized reaction we always give salts and water. Got it? Now let's move forward. Now we having the strong bases phenomena. Like base is a substance which form OH minus ions. OH minus ions. Okay, and remember in a previous lecture I had told you during the acidic part, like the more will be the hydrogen, more will be the acid, because acid gives H plus ions. Acid gives H plus ions. Similarly, in this case, you can say base gives OH minus ions. So we can say the higher the OH minus ions will be, the more will be the basic. The less OH minus ions will be, the less will be basic. Got it? So this is the strong basis phenomenon. Got it? Similarly, like the weak basis, the thing which we have discussed now is the applicable thing in this scenario. Like weak bases are the one who partially dissociate in water, means the OH minus ions is less in water, and whenever it is less in water, then the condition will be of weak bases. Okay, like the ammonia is example of weak base. Got it? Now we have reached the salt part. Okay, we have reached the salt part. So basically, what do you mean by salt? Whenever I ask you what do you mean by salt, then you always think of the table salt. Think of the table salt. Okay, the common salt which we generally use in a household is also known as sodium chloride. also known as sodium chloride. Okay, and basically how does it form? Sodium chloride is basically formed because of the atomic combination of sodium with atomic combination of chlorine. Okay, so this is the basis behind the formation of sodium chloride. Like you can say, if it is a sodium, then it is a chlorine, and when they both combine, they form sodium chloride. They form sodium chloride. Got it? So it is the basic property of formation of the sodium chloride, and sodium chloride is basically used in our common households. Got it? Now remember one thing. What about the oceanic water? Whenever the oceanic water counts in your mind, what do you think? The oceanic water is always salty. Okay, and whenever you talk about the river water, it's always fresh water. It's always fresh water, because in oceanic water there is a dissolvent of salts. In river water, no such thing is there. No such thing is there. Got it? And how do you find out the substance placing in front of you is salty or not? Like if I give you a glass of water, like 2 glasses of water, this one and this one, and I ask you, tell me which is the oceanic water and which is the fresh water. So what you can do, you have to sip from both of the glasses, and then you will be able to tell me that, sir, this is an oceanic water and this is a fresh water. But how the water taste define that whether it is an oceanic or riverine? Because salts having taste of savory, whereas the fresh water, no such thing. Fresh water does not having any savory taste. Got it? So when you trying to drink this water and if you find that it is very savory, then you can say it is an oceanic water. But if you find water taste is a neutral, you can say, sir, it is a river water. Got it? So it is the indication, or you can say that's how you can find out whether it is a oceanic water or the fresh water. So what are the salts commonly found in the oceanic water? Let's discuss it also, so that we could get the better understanding of this topic. So basically, there are 6 types. There are 6 types of salts commonly found in oceanic water. So there are basically 6 types of salts commonly found in the oceanic water. And what are these types? Let's discuss them one by one. So first one. First one, second one, third one, fourth one, fifth one, and the sixth one. First one is a sodium chloride. Second one is a magnesium chloride. Third one is a magnesium sulfate. Fourth one is a potassium chloride. Fifth one is a calcium carbonate. Third one is a magnesium bromide. So basically these are the 6 types of salts which we found in the oceanic water. And remember, the arrangement of these salt from number 1 to number 6 is done on their basis of concentration in the oceanic water. Or you can say, if this is a beaker in which the oceanic water is placed, then this oceanic water having 6 type of salt, and these salts are like sodium chloride. These salts are like sodium chloride, magnesium chloride, magnesium sulfate, potassium chloride, calcium carbonate, and magnesium bromide. Okay, and these salts are basically placed on their concentration in oceanic water. The highest concentration stands for the sodium chloride, which we also use in a household. Second one is our magnesium chloride. Third one is our magnesium sulfate. Fourth one is our potassium chloride. Fifth one is our calcium carbonate. And sixth one are magnesium bromide. Got it? So after this, let's have a look upon what are the properties of the salt. What are the properties of the salt? So there are basically some properties of the salt which we need to discuss. So the first is salts are basically crystalline solid. Second one is they may be transparent or they may be opaque. Third one is they may be salty, sweet, or bitter. Fourth one is they may be colorful, or you can say colorless. Okay, and remember always, neutral salts are odorless. So these are some of the properties of this salt which we need to discuss. First is our crystalline solid. Whenever you look at the salts, you will always find that they are crystalline in nature. You can also check it with your sodium chloride or your common household salt. If you look at it, then you will find that it is a crystalline in nature. Second one is they may be transparent or they may be opaque. Okay, whether it will be like this, transparent, and it will be like this, opaque, completely opaque. No light could be passed through it, so it will be opaque. Okay. Third point is the salts may be salty, sweet, sour, and bitter. Out of these 4 tastes, it may have any one taste. Okay, so they may be salty, they may be sweet, they may be sour, and they may be bitter. Okay. Fourth one is they may be colorful or colorless. They may be colorful or colorless. Like this one. If you just take an example, this one is red color. This one is red color. Okay. But if you look at this one having no color. Got it? So this is a example of this fourth option. And the last one is that they are neutral salts are basically odorless. Neutral salts are basically odorless. They do not having any smell. Got it? So this is about the properties of salts which we have finished. Okay. Now discuss about the types of salts. So let's start. First is the reaction of neutralization, which we should understand. As I have told you, whenever acid reacts with base, it will always neutralize. It will always neutralize and will give salts and water. Okay, salts and water. So basically salts are generally obtained because of the process of the neutralization whenever the acid react with the base. Neutralization is a chemical reaction between an acid and the base, resulting in formation of water and a salt. H2 ions, which is found in acid, combined with OH minus ions from the base to form water. Okay, this one. Got it? And the remaining ions which never or not taking part in the water formation will form the salt, and that's how it became salt and water from acid and the bases. Okay, and remember this is the exothermic process. So whenever the process will be taking place like this, acid reacting with the base and you will getting salts and water, then during this formation a large amount of heat will be released. So it is a exothermic process. Got it? So it is about the neutralization. Okay, so now let's move forward. Whenever this reaction of neutralization taking place, then the cation from the base will combine with the anion from the acid. Cation is always positive, anion is always negative. Got it? So also note down this, like whenever the reaction of neutralization taking place, the base donates the cation part, positive part, acid donates the anion part, negative part, and then they both get combined together. Okay. Now we having types of salt. First is a neutral salts. Most common types of salts form when a strong acid reacts with a strong base. You can say the acid is strong, the base is strong, so that the product which they will form, AB, basically the salt, will be neutral. Neither it will be positive nor it will be, neither it will be negative nor it will be positive. Got it? Because both are having equal powers, whether acid or base. Okay. Second one is a acidic salt. Basically it's happen when the acid is strong and it reacts with the base which is weak. So in that case, the salt will be acidic because acid having more power in this case. Okay. For example is sodium hydrogen sulfate. Got it? Now let's move forward. Acidic salt, these are salts when a weak acid, and now the double salts. So now let's move forward. First is our acidic salt. So basically the acidic salts form when strong acid reacts with the weak base. Whenever the strong acid reacts with the weak bases, there will be a condition of acidic salt, because in this condition the acid will take over the basic part. Okay, so whenever the acidic reacts with the base but the acidic part is strong in comparison with the basic part, the acidic salt will be formed. For example, sodium hydrogen sulfate. Now come to the next point. Now the basic salt. Basically, basic salt is a reversible condition where the strong base react with the weak acid. In this scenario, the acidic part is weak and the basic part is strong. So the basic part overtakes the acidic part. The example is calcium carbonate. Got it? Now, double salt is a compound formed by a combination of two simple salts, typically with a water of crystallization. Okay? Whenever there are two salts like salt 1 and salt 2, they both combine together to form salt 1,2. Okay? So in this scenario, the salts which having a different properties, maybe they are salty, maybe they are sweet, okay, but they both get combined together and formed a different property from their original one. Like example, if it is a salty nature, it is of sweet nature, when they both combine together, they form a distinct characteristics from their original one. Like the 1,2, maybe the sweet, maybe the salty, or maybe the sour or bitter, any of the thing. Got it? Now let's move forward. Is a hydrated salt when simply in salt parts there is a presence of water crystals. Water crystals. If the thing is there, then it will be a hydrated salt. Okay, and the water molecules are basically called the water of crystallization. Got it? And which can affect the color and stability of the salt. The example of this is magnesium sulfate heptahydrate. This is an example of hydrated salts. Got it? Now let's move forward. Is a anhydrous salt when water crystallization has been removed. Whenever such thing happen, it is a form of anhydrous salt. And anhydrous salts often have different properties compared to their hydrated counterparts, because their hydrated counterparts having the water, which could affect the color and the stability of the salt. Got it? Now, complex salt basically formed by the combination of various metal ions and the ligands, and these ligands can be neutral molecules or anions that coordinate with the metal ion. Okay, just remember this line. Complex salt compounds combination of metal ions and the complex ion or ligands. These ligands may be neutral molecules or ions that coordinate with the metal ion. Just remember these lines for the complex salts. And the best example of is potassium ferrocyanide. Got it? Now the binary salt having two elements, they can form from the reaction of metal with a non-metal. And the best example of it is sodium chloride, where sodium is a metal and chlorine is a non-metal. But they both combine together to form a common salt, which we call the binary salt. Got it? Now the ternary salt having three different elements, two different elements may be the non-metal anions and one will be a metal cation. So you can say one will be a metal and two will be a non-metal, and they all combined together will be a 3. Got it? So if such condition happens, it is a ternary salt. Okay, best example of it is sodium sulfate. Thereafter, the last one is the substitutional salt. Basically, in this salt, some of the ions in the crystal lattice are replaced by other ions of similar charge. So, the crystal lattice ions of this salt will be replaced, but the one which will replace them will have to have a similar charge. If it will have a similar charge, then only it will be able to replace it. Okay, so basically these are the different types of salt and their application in industries which we have discussed. Okay, how they formed, and also we have discussed about the basic part, neutralization part, and other important phenomena. Got it? In our next lecture we will start with the organic chemistry. Till then, thank you.